This is the second part of the functional skills sample paper from City and Guilds, where you can use a calculator. There are 45 marks in total. Question number 1. 0.06 million divided by 6.2 thousand is equal to what? Give your answer to 2 decimal places. I'm going to rewrite these numbers. 0.06 million. I've written it this way with the zeros after, so that it's going to make it easy for me to just write the number out, because this is now equal to 60,000, as you can see. Rewriting this one, 6.2 thousand, and we know that thousands have 3 digits after. So 1,000. So this is written like this, 6,200. So we've got to divide 60,000 by 6,200. Using a calculator, this gives us 9.6774 and so on. So rounding this to 2 decimal places means we've got to have only 2 digits after the decimal point. So this becomes now 9.68, because this is higher than 5. What is 3/87 as a decimal? Correct to 3 decimal places. 3/87. So I'll use a calculator, and it gives me 0.034482 and so on. So need to round this to 3 decimal places, so having 3 digits after the decimal point. And since this one is less than 5, I'm going to keep this digit in front of it as a 4. So 0.034. The diagram shows the outline of a building. We've got the front. Which one of the above shows the elevation of the left side of the building? So the left side would be looking at this in this direction from this side, and that would be option C. Question 4. 1 cubic meter is the same as 100 cubic centimeters, 1,000 cubic centimeters, 100,000 cubic centimeters, 1 million cubic centimeters. Okay, so we know that we need to multiply length by width by height to get volume, which is expressed in cubic units. So we've got, let's suppose we have 1 meter by 1 meter by 1 meter, and we want to convert it to centimeters. So 1 meter is equal to 100 centimeters. So 100 centimeters, 100 centimeters, 100 centimeters. So we know we need to multiply all three of them to get volume. So we'll go 100 times 100 times 100, which is equal to 1 with 6 zeros after. So we'll separate them into threes, and that is 1 million, which is option D. The social club sells 50 pink raffle tickets and 75 yellow raffle tickets. Tickets are drawn randomly. What's the probability that the first ticket drawn will be a pink ticket? Give your answer as a decimal. So we're looking at pink tickets, and there are 50 pink tickets out of, in total, we've got 50 and 75, so it's 125. So 50 out of 125, and that gives us 0.4. Question number 6. The chart shows finishing times of marathon runners. The report says that most of the runners finished in under 4 hours. Is the report correct? Explain your decision. So we're looking to compare 4 hours and over with under 4 hours. We could say that the report is not correct because the area on the right is greater than the area on the left. Or we could specify and add these by estimating. So this is 25k. This is about 70k. And we've got this being 95. 75 perhaps here, maybe 45, 30, well, at 25, 15 and 10 perhaps. So if we add them up, we can see that they're not equal. So we're going to say that the report is not correct and more than half the runners ran for over 4 hours. A shop has a sale. There is 30% off all black tag items. One day this notice appeared in the shop. One day only, black tag, an extra 25% off marked reduced price, better than half price. Customer complains that the notice is misleading because it's not true. Is the customer correct? It's always easy to pick an example in here and start from there. So if we have an item that would normally cost £100 and then you take off 30%, so you left, so minus 30%, you're left with £70. Now we've got an extra 25% off. So 25% off 70, that is 1/4 of it. Half is 35, so half of 35 now to get 1/4 of 70 £17.50. So taking that away from 70 leaves us with £52.50. Okay, so is this better than half price? No, it's not, because otherwise you'd have been less than £50. So the customer is correct. We've shown all the working out above, and the explanation is that when an item costs £100, taking off 30% and then 25% of the reduced price leaves us with £52.50 to pay, which is higher than half of the price, the full price. A craftsman uses resin to make paperweight. He makes the paperweight from two parts, a hemisphere and a cylinder. He uses this plan, and we've got the shape given to us. How much resin does he need for both parts? So it's quite clear that we're working with the volume of the hemisphere as well as the cylinder. So working out the volume of the cylinder first, we know that the diameter is 6 centimeters, we can see here. So the radius will be 3 centimeters. So pi r squared is the formula for working out the area of the top of the cylinder. So in this case, we've got pi, which is 3.14, times 3 squared, which is equal to 28.26. Now we need to multiply that by the height of cylinder, which is equal to 5 centimeters, and we can see that here. So 28.26 times 5 equals 141.3 cubic centimeters. So that's the volume of the cylinder. Now the volume of the hemisphere, we've got the formula here. So two thirds of pi times the radius, which is 3 cubed. Plugging that into the calculator gives us 56.52. So adding that now to the volume of the cylinder gives 197.82 cubic centimeters. So that's how much resin he needs in total. 197.82 cubic centimeters. Moving on to question 9. A gardener wants to build this greenhouse in the top right-hand corner of her garden. This is a sketch plan for her garden. She would leave a 50 centimeter space between the greenhouse and the edge of the garden. She wants a scale plan of the garden showing the position of the greenhouse. Draw a scale plan, put the scale you use on the plan. So we've got this grid in here. These squares measure 1 centimeter by 1 centimeter each. We've got 13 squares going across, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 going down as well. So looking at the dimensions of the garden, 5.5, we could have 2 squares representing 1 meter. So 2 squares will be equal to 2 centimeters, representing 1 meter. This scale would mean that the plan of the garden will be big enough to be seen, but at the same time would fit into this plan. So we'll start. So I'm going to leave 1 square space both sides. So that should be 11 squares. And we'll go 11 squares down as well. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let's see how many squares we need to go down here. So it's 4 meters, it's going to be 8 squares. 1, 2, 3, 4, 5, 6, 7, 8. And we need to go across. So 5.5 meters, take away 2.5, that would give us 3 meters. So 3 meters will be equal to 6 squares. So we'll adjust this. One, 2, 3, 4, 5, 6. Let's just double check this one. So 5.5, take away 4, leaves us with 1.5, which would be equal to 3 squares. And that is what we've got. And finally, this 2.5 meters length, which is represented by 5 squares here. 1, 2, 3, 4, 5, which is correct. So we've represented the plan of the garden in here. Now we're going to need to do the greenhouse. So we know that the dimensions are 2 meters by 2.5 meters, and we need to leave a 50 centimeter space between the greenhouse and the edge of the garden. So 50 centimeters in terms of the squares, it's going to be 1 square. So we've got to do this on the right of the garden, right hand corner of the garden. So let's just start then, leaving a 1 square gap both sides. So starting from the right, 2 meters by 2.5. So 2 meters will be 4 squares. And the other side is equal to 2.5 meters. So it's going to be 5 squares. Two, three, four, 5. I could have done 2.5 meters this way and 2 this way, and both of them would have been correct because it hasn't been specified in here. Let's just double check. That looks good so far. So we just need to do the other 2 sides. And we'll do so. And we're going to label them. So we've met all of the criteria that's been set. So we can move on to the next question. Question number 10. A student wants to raise £100 for charity. He will sell hot dogs at a disco. He will make 150 hot dogs. He buys the ingredients at the supermarket. So we've got hot dog sausages, tin of 8, 50 pence, and hot dog buns, packet of 6, 90p. If he sells all the hot dogs, what's the minimum price he must charge to make a profit of £100? Okay, so let's start with working out the price of making 150 hot dogs. So we've got the sausages, tin of 8. So how many do we need? How many tins? 150 divided by 8. 8 into 15 fits only once. So we've got 7 left. 8 into 70. feeds 8 times, so that is 64. So we'd have a decimal point there, and there we go, into 60 and so on. So there's going to be a digit over here, which we're going to put as 7. However, we can't buy 18.7 tins, so we're going to buy 19 tins of hot dog sausages. So we're going to go 19 times 50 pence, which is 950 pence, and that is the same as £9.50. Now we've got to work out how many packets of hot dog buns. They are in packets of 6, so we're going to go 150 divided by 6, and you could do this with a calculator as well. So that would be 2 lots, 12, 30, 25 of them. So 25 times 90, which is 2,250 pence, which is equal to £22.50. So we need to add to that the £9.50. That makes £32 in total. So that's the cost. He needs to make a profit of £100. So altogether, they must bring £132. So it's 150 of them. So we're going to divide that by 150. So that is 0.88. So the minimum price that he must charge to make a profit of £100 is 88 pence. A supermarket buyer compares large eggs from 2 suppliers. She wants to buy the largest eggs. The table shows the masses of a sample of large eggs from supplier A. A similar sample taken from supplier B gives a mean value of 66.5 grams. Which supplier should the buyer use? Explain your decision. So we're going to estimate the mean here. We've got a range between 63 and 65. So the mid value is going to be 64. Then we have 66 here, 68, 70, 72, and we're going to multiply by the number of eggs for each of them. So now 66 times 27. I'm going to add them all together. Dividing this by 100, which is the total number of eggs, gives us 67.28, which is higher than the 66.5 grams that we have. So which supplier should they use? They should use supplier A. And decision, and we've shown all the working out. Explaining the decision, because the estimated mean is higher for A. A man has £5,000. He will put this money into a savings account. He wants to save it for 1 year. Bank A pays 2% compound interest. It adds interest every 6 months. So that is every 6 months, so twice a year. Bank B pays 3.15% annual interest rate. So that would be simple interest. Which bank should the man choose? Explain your decision. Include calculations to support your decision. We'll do Bank A first. 2% compound interest. So he invests £5,000. Now you could work out 2% and add it on top, or just go times 1.02 to the power of 2, because it's going to be twice for the year. And that gives £5,202. Now that was Bank A. Looking at Bank B, 5,000 times 1.0315, and we wouldn't square that because it's just paid once during the year, and this is equal to £5,157.50. So he should go for Bank A. And we can write something like you will get more money for the investment by using Bank A. Question number 13. A magazine article has this headline: Garden birds in decline. Fewer birds seen in our gardens. An environmental organization records information about bird populations. The graph shows some data about 2 types of garden birds. So we've got them both in here. We've got chaffinch and sparrow. So is the magazine headline correct? Show suitable calculations of percentage changes for the last 10 years and draw trend lines on the graph to support your answer. Explain your answer and make 2 comments. We'll start by drawing the trend lines. This is just the line of best fit, basically. So we need the line to go through the dots, having an equal distance between the ones at the top and the ones at the bottom. And that looks like it. So we can see for chaffinches that the trend is downwards. Let's look at sparrows. Two and a half, 2.5. There is no downwards or upwards trend when it comes to sparrows. We'll now show some percentage changes. So using the line of best fit in here, this is about 3.7 in year 2009, and then about 1.95 or 2 in year 2018. So it's gone from 3.7 to 2. That is 1.7. So 1.7 out of the original value, which was 3.7. So that gives about 0.46, which is 46%. So there's been a 46% decline for the chaffinch bird. So we can write a comment here. There has been a 46% decline for chaffinch bird in the last 10 years. In terms of the sparrows, so we can say the average number of sparrows seen has remained constant in the last 10 years. A team manager wants to pick 4 people for a bowling competition. She decides to pick players with consistently good average, median scoring performances. She picks the following 3 people. We've got Archie, Baz and Kathy, average scores over the last 8 matches, and the range of scores over the last 8 matches. She needs 1 more player to make up the team. She looks at the scores of 2 more players. Scores in last 8 matches. We've got Dave and Elaine. Make suitable calculations for Dave and Elaine. Decide which player best fits the requirements. Explain your decision using figures. So since the median has been used before, we're going to use the median to work out the average for Dave and Elaine. So we'll put the scores in order. 48 is the lowest, and then we've got 67, 78, 86, 96, 98, 101, 102. And for Elaine, we've got them in order: 79, 84, 87, another 87, we've got 93, 97, 98, 101. So crossing them out each side, we've got 86 and 96. So 86 plus the 96 divided by 2 was 91. 87, add 93, divided by 2 equals 90. So the median is higher for Dave, but if we look at range, which is another thing that she's looking at, for Dave we've got 102, take away 48, which gives us 54. And for Elaine, that is 101, take away 79, which is 22. So although the median for Dave is slightly higher, we'll go for Elaine as she's more consistent, and the range tells us that. So both have similar medians, but Elaine is more consistent, and the range tells us that. Question 15. A fisherman sets off from Dunsey in a boat. His boat will travel at an average speed of 5 kilometers per hour. He has his map so that he can avoid the rocks. He needs to meet up with the ship at coordinates L34 at 5 p.m. He needs to know at what time he must leave Dunsey. So that's our question. L34. So he's going from Dunsey, which is here, to L34. So there we have L, and there we have 34. They meet at this point here. So gets in from this point, avoiding the rocks. So I would go up here. We could go higher up. We want to avoid the rocks, so I'm gonna go up to this point and then across. Again, we've got the rocks on the way, so I'm tempted to go a bit further away up to this point and then come down and then get there. So let's have a look. 1 square is worth 1 centimeter. So we get 1 full centimeter here, 2, 3 centimeters, 3.4, 4.4, 5.4, 6.4, 7.4, 8.4, 9.4, 10.4, 11.4, another 2, 11.6, 11.6, 7.8, 12.8, 13.8, 13.9, 14. So we've got 14 centimeters. So 14 centimeters. The scale is 1 to 25,000. So if 1 centimeter is equal to 25,000 centimeters, then 14 centimeters on the map will be equal to 14 times 25,000 centimeters in reality. So we can use a calculator to get that. And it gives us 350,000 centimeters. So we'll convert this to kilometers now, because that's what we need. It says in here that he travels at an average speed of 5 kilometers per hour. So we'll need that piece of information. 5 kilometers per hour. So 350,000 centimeters. We'll convert this to meters first, and we know that there are 100 centimeters in 1 meter, so we're going to divide this by 100. So we're literally knocking out the 2 zeros at the end. So we've got now 3,500 meters. Now we'll try and convert this to kilometers, and we know that there are 1,000 meters in 1 kilometer. So we'll divide 3,500 by 1,000, and that gives us 3.5 kilometers. So if it takes 60 minutes to do 5 kilometers, then how long does it take to do 3.5 kilometers? So to get from 5 to 3.5, what are we multiplying by? So we'll do that by dividing 3.5 divided by 5 gives us 0.7. So 5 times 0.7 gives us 3.5. We do the same on the other side, so 60 times 0.7 gives us 42 minutes. So if it takes 42 minutes to get there, what time must he leave so that he arrives at 5 p.m.? So we go in 5 p.m. We're going backwards by 42 minutes. We can go backwards by 30 minutes first to get 4:30 p.m. and then another 10 minutes to get to 4:20 p.m. and another 2 minutes to get to 4:18 p.m. This is the end of the paper.